Hi guys, this is A2 Chemistry, Transition Elements, and we're looking at isomerism in complexes. Question 11. Define the term transition metal complex. So, a complex is a molecule or ion consisting of a central transition metal ion surrounded by one or more ligands. So, that is the definition of a transition metal complex. Next, platinum can form the compound shown. State the coordination number and the oxidation number of the platinum in the two ions in this compound. So, in the first compound, platinum is surrounded by four ammonia molecules and two chloride ions. So, in total, there are six monodentate ligands surrounding platinum. So, the coordination number of this complex is six, and the oxidation number of platinum would be X would be here. This is 0, this is -2, and all of this is equal to +2. So -2 on the other side goes to +2. So +2 and +2 gives us an oxidation number of +4 for platinum. Next, we have four chloride ions with a -4 charge. X minus 4 equals -2. So -4 on the other side becomes +4. +4 minus 2 gives us a charge of +2 for platinum in the second complex. And since there are four chloride ions surrounding platinum, which means there are four monodentate ligands, therefore the coordination number of platinum, or rather the coordination number of the complex here is 4. Draw three-dimensional diagrams to show the structure of the two isomers of platinum with four ammonia and two chlorides. So if there are two chlorides, so we can show cis and trans conformations. So we would have the central metal ion as the platinum ion. Then we would have positions for substitutions for both the ions as represented by octahedral complexes. And once drawing those positions are complete, we would place the ligands in such a way that one of the isomers shows that it is a cis isomer and the other one shows that it is a trans isomer. So in a cis isomer, the two chloride ions would be placed adjacent to one another, and in the trans isomer, the two chloride ions would be placed diagonally opposite to one another. So now let's place those chloride ions. So next to each other, we can place them this way on adjacent positions, and diagonally opposite can be placed in this way. So we label this as the cis isomer and this as the trans isomer. Now all the remaining positions will be filled out by ammonia. So NH3, 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 NH3 on the cis isomer, and the remaining positions on the trans isomers will also be occupied by the monodentate ammonia ligand. So in this way, we have placed all four of the ligands. Now, in order to complete the structure, we draw the square brackets and place the charge of 2 positive on them so that the diagram is complete. So here we have the cis and the trans isomers of the given complex. Solutions of the compounds PTNH3 4 times Cl twice and Br twice, and PTNH3 4 times Br twice Cl twice. So the difference between these are, in the first one the chloride are the ligands and Br2, that means two Br negative ions are the anions, and in the second complex Br2 are the ligand and the Cl2, which means two chloride ions, are the anions. Can be distinguished from one another or each other by a simple chemical test. Assume that any species bonded to the platinum ion does not react in this test. Complete the table with a test that could be used to positively identify each compound. Give details of the expected observations with each compound. So the test that we can perform is we can add acidified AgNO3 aqueous and we acidify it with HNO3 so that the anion remains the same. And the observation that we would obtain would be in the case of the bromide anion, it will react with the silver cation producing a cream precipitate. And in the case of the chloride anion, it would produce white precipitate with silver cations. And in this way, we can distinguish between the two compounds. Next, in this question, you should consider geometrical and optical isomerism. Okay. What type of isomerism is shown by the following complexes? You should answer geometrical, optical, both, or neither. Okay. So, octahedral complex with two bidentate ligands and two monodentate ligands. So, there are two monodentate ligands. They can be placed either adjacent to each other and diagonally opposite, forming cis and trans isomers, and the cis isomer can have a non-superimposable mirror image which should be its optical isomer. So in the case of the octahedral complex we can have both type of isomerism occurring. In a square planar complex with two different types of ligands we can only have geometric isomerism taking place. And in the third option, a tetrahedral complex does not have any isomerism taking place in it, so it would have neither. Question 12. Adding a measured quantity of KCN to a solution of NiCl2 produces a complex NiCN twice Cl twice. Reduce the overall charge X on this complex. So NiCl twice would have a net charge of positive 2 on nickel and negative 2 on chloride. So that will stay in the complex positive 2 and negative 2. And in KCN, we will have plus 1 and minus 1. So in total, the CN negative charge would be minus 2. So plus 2 and minus 2 cancels out. We are left with minus 2. So the overall charge on the complex end would be negative 2. So the answer here is negative 2. The complex can exist as two separate isomers with the same geometry around the nickel ion. So we've got two CN ligands and two Cl ligands. So if they can form isomers, that means the type of complex is a square planar complex. State the type of isomerism shown by these isomers. So in square planar complexes, the type of isomerism shown is cis trans, which is also called the geometric isomerism or geometrical isomerism. If bromide ions are present in the solution, the complex NiCN twice ClBr can form. Assuming that this complex has the same geometry as NiCN twice Cl twice, state the number of isomers, the complex that could exist, and draw their structures in the box. So, since it's a square planar complex, there are two possible isomers that can form. One isomer would have a nickel atom bonded by four ligands, two of which would be Cn, and the position of those Cn ions would be on the adjacent position. So Cn and Cn. This makes it a cis isomer. And the position of a Cl and a Br would be on the remaining two dative bonding positions. Similarly, we would have another isomer in which there would be a central nickel ion, and this time the two CN groups will not be present adjacent to each other. They would be positioned diagonally opposite to one another, forming the trans isomer. So a CN here and a CN here. And the remaining two positions are occupied by the halogen ions. And this is what is known as the trans isomer. Question 13. Copper is a transition element with the atomic number 29. Complete the electronic configuration of copper atom and a Cu positive ion. So the electronic configuration of copper atom would be 1s2 2s2 2p6, 3s2 3p6, 3d10 and 4s1. And in the copper plus ion, the 4s1 electron would be lost, and the remaining of the electronic configuration would be 3s2, 3p6, and 3d10. Cu positive ions form a linear complex with the chloride ions, which are monodentate ligands. Draw structure of the complex and include its overall charge. So, in a linear complex, we would have a central copper ion, which has a +1 charge, and this would be bonded to by two chloride ions, and the overall charge on this complex would be a positive charge for copper and two negative charge for two chloride ions. So in total, a -1 charge on the complex ion. So this is the linear complex that Cu positive ion forms with two chloride monodentate ligands. Cu2 positive ions exist as CuH2O6 2 positive complex ions in aqueous solution. Complete a three-dimensional diagram to show the shape of this complex. Name its shape, label and state the values of one bond angle. Okay, so the shape would be octahedral. These would be the position of binding of the six water molecule ligands, and the bond angle between each of these bonds would be 90 degrees. So water would be placed on each position with the oxygen atom forming the dative covalent bond with the central copper ion. So we have completed the formation of the ion, and next we would put the ion in a square bracket because it has got a net charge of +2. And they've asked for the name of the shape. The name of the shape is octahedral. Ethane diode ion C2O42 minus can act as a bidentate ligand. Explain what is meant by the term bidentate ligand. So we have to combine the terms bidentate and ligand together in a single definition. So it will go as a molecule or an ion consisting of two lone pairs of electrons that form two dative covalent bonds with the central transition metal ion. So A bidentate ligand forms two dative covalent bonds, and a ligand forms dative covalent bonds. So, combining the two definitions together, we have something that forms two dative covalent bonds because it has got two lone pairs of electrons. When ethane diode ions are added to a solution of zirconium ions, Zr4 positive, a complex ion consisting of four C2O42 minus ions and one Zr4 positive ion is formed. All four ethane diode ions act as bidentate ligands in this complex. Give the formula of this complex ion and explain why this complex is not octahedral. So, the formula of the complex is Zr C2O4 4 times. Whole charge would be plus 4 and minus 8, which would give us a net charge of minus 4. And the next thing that has been asked is to explain why this complex is not octahedral. So, since there are four bidentate ligands attached to the zirconium ion, that would mean each ligand would form two dative covalent bonds. So in total, there are four dative covalent bonds, which mean eight dative covalent bonds, which means that the coordination number of the complex is 8. The coordination number of an octahedral complex is 6. Therefore, this complex is not an octahedral complex. Question 14. Ethane diode ions C2O42 minus are bidentate ligands. Cr3 positive aqueous and C2O42 minus ions forms the complex ion Cr2O4 twice H2O twice. So there are two bidentate and two monodentate ligands in this complex. Draw two stereoisomers of this complex. So if there are two monodentate ligands, so they can be positioned either next to each other, which would form a cis isomer, or they can be positioned diagonally opposite to each other, forming the trans isomer. And the remaining positions would be occupied by the C2O42 minus ligands. So these are the positions of the binding of the C2O42 minus ligands on both these complexes, thus completing the structure of the complex. Then we make the square bracket and place the negative charge on it to complete the diagram of each of these complexes. Question 15. 1,2-diaminoethane or EN is a bidentate ligand. Explain what is meant by the term bidentate. So it is a molecule or an anion having two lone pairs of electrons that form two dative covalent bonds with a transition metal ion. Next, Cu2 positive ion and En forms the complex CuEn thrice. Draw the two optical isomers of this complex. You may use the skeletal formula to represent En. So, we need to draw optical isomers, which means we will color code the En to understand which position the mirror images are for each molecule. So the first one has been color coded with blue, the second EN has been color coded with red, and the third EN has been color coded with olive green. So this way we have got two mirror images. Now in order to complete the complex, let's draw the mirror and the square bracket with the two positive charge on the outside so that the entire complex diagram is complete.